I have aliased a M code, and I have also aliased a G code, and I have also written a Visual Basic add-in that accesses data in FeatureCAM's tool crib, and it also accesses data in FeatureCAM's tool holder crib and generates a subprogram that automatically inserts all pertinent data into the tool offset table. This is what the Visual Basic code looks like. If you're interested in how it actually interacts with FeatureCAM and this, that, and the other, it'd probably be better just give me a call and I can explain it to you better. This is actually an update of a previous Visual Basic add-in that I wrote many years ago. This is what the beginning of the subprogram looks like, and you'll notice it starts with this M888 M code. And what it does is it clears out a bunch of the redundant data that, after doing a bunch of different setups and jobs, just kind of seems to accumulate in the tool offset table. But most importantly, what it does is it clears out the tool probe type. So what's important about the M888 code clearing everything out is once we actually start to run the subprogram, it's only going to populate the tools that are going to be run with that job with things like probe type, approximate tool diameter, approximate tool length, and stuff of that nature. So what ends up happening is when you look at the tool offset table, only the tools that you're going to be using for that given job are going to have those values in it. So now the subprogram's getting ready to actually start loading data back into the tool offset table. And some of the data is kind of useless, but I figure if the software can automatically do it without any effort on my part, why not? And then also, particularly with the tool diameter, in the past I always did that with a G10, whereas this time, I don't know, I just decided to just set everything directly using variables. So it starts off first by putting in the number of flutes, which, you know, is kind of pointless, but again, if it can read it from FeatureCAM with no effort, why not? And then it puts in the tool diameter, which, again, you need that, and well, for me, I need it because I do tool diameter compensation, and so it just guarantees that no matter what, the person setting the job up can't forget to enter a value or enter a value incorrectly. And then the approximate diameter, I'm just having it throw that in there. I'm not totally sure if I'm ever going to do a probe type 3 just yet, so it may or may not be needed. And then the actual diameter, which isn't really needed, but I don't know, like shows your surface speed properly all the time. And then the probe type, I have some intelligence in there so that depending on the type of tool and the size of the tool, it'll either select a 1 or a 2. Eventually, I may do a 3, but at this point in time, I'm kind of undecided. And then the edge measure, I just have it clearing that out. Eventually, if I do decide to start using probe type 3, then I'll start putting data in there. And I may end up just moving that to the M888 command. Time will tell with what I do with that. And the same thing's true with the tool tolerance. Eventually I'll take and decide what I'm going to do with that. Right now I'm just having it cleared out. And then the next thing is we have the approximate length, which obviously it just reads from the tool crib the gauge length off the holder and the approximate length of the tool and adds them together and then enters that. And then we come to the most interesting line, which is this G8 line of code, which is a G code that I aliased. So I could have most certainly had the Visual Basic add-in do all the calculations that this G8 code is doing. However, I felt that it was probably better to have that on the machine's control because it gives me more flexibility in the fact that I'd have to have different add-ins for different machines because like a VF P-cool positions are totally backwards from UMC P-cool positions. And just with how the machine's built, it just made more sense to have this in alias G code. What this does is, with one line of code more or less, we go directly from an approximate tool length to an integer value for our P-cool position. As you can see, we do some error checking before I put the approximate length into the function, and then some error checking on the output, and what before we write it to the tool offset table. But what this is that this single line of code is, I modeled the data and generated a second-degree polynomial to emulate the positions of the P-cool versus approximate tool length, and then using the round function, obviously, chops off the decimals and converts it to an integer, which very nicely goes into the tool offset table. So I was actually pretty proud of myself to do an actual complicated line of code that. And again, there's a shift value also at the top, so in case I find, that it's routinely calculating the positions like off whatever, I can just take and adjust that. And also, too, I like the idea of this sub-program, could run on, virtually any HAAS machine because the G code for the P-cool position resides on the machine and can be tweaked, to whatever machine, essentially just by rewriting that function. And, I suppose you could maybe do like a y equals mx plus b to try to model the data, but the second degree polynomial did a better job of it. And just like any other CAM system, FeatureCAM obviously generates, setup sheets automatically. And with the way the setup sheets are created, there's an exposed length, and then it also says what tool holder to use and even the part number of what that tool holder is. So long as the machinist setting the job up can grab the right tool holder and set the exposed length properly, there's absolutely no need for them to manually set or measure the approximate length of the tool. So in summary, every time I post a program, I have a very automated way to automatically insert all pertinent tool data into the tool offset table and not have to manually measure any of the approximate tool lengths or set any of the P-cool values.